When it comes to manufacturing electric vehicles, Tesla is in a unique position in the industry. As the most vertically integrated company in the automaking world, Tesla has the ability to attack any piece or component of its vehicle or the manufacturing process to make it better and more cost-effective. This is what Tesla has done with the new revolutionary tabless batteries it is going to be using in its future electric vehicles. Tesla announced a new tabless battery on its Battery Day event last year to critical acclaim. It was not just an academic exercise for Tesla, as it was born out of a specific need. Like other battery makers, Tesla has been purchasing its battery cells from suppliers that use their own proprietary chemistry and structure. This was working well until Tesla looked into the future and discovered that its battery supply chain could cause a problem. Tesla's target is to sustain a 50% year-on-year growth in total vehicle output. For instance, last year, Tesla shipped nearly 500,000 electric cars and set a target of 750,000 for 2021. All these cars will only be shipped if they have a battery in each of them. The problem was that according to its forecast, the growth rate in the current production of batteries would not be able to match Tesla's growth ambitions, creating a bottleneck down the road. Simply put, a time would come when Tesla would finish making its vehicles but need to wait for batteries to be finished up before installing them. The culprit here is the manufacturing process of the batteries, and we shall see more on that later. That is a scenario Tesla wants to avoid at all costs. As a result, Tesla set to work on the core components of batteries as we know them, and came out with the tabless 4680 battery. While the battery is a complex concept best left to the experts, it is possible to have a general idea of what Tesla has done here. The common cylindrical lithium-ion battery uses cells made of several layers or strips of chemical compounds to store energy. The layers are the cathode and anodes with a separator layer in between them. The cathode layer and anode layer then connect to the positive and negative terminals of the battery using small metallic components known as tabs. The problem with tabs is that they could be the downfall of the whole battery, despite performing a crucial function. They can affect the battery performance and reliability if not done right. For instance, when the tabs are welded onto the electrodes, they could be resulting welding burrs that can pierce the layer between the cathode and anode layers, causing an internal short circuit. This has the potential of causing a fire. Also, the step of inserting the separating layer between the cathode and anode layers introduces a time-consuming procedure during the battery manufacturing process. What Tesla managed to do is to eliminate the need for the connecting tabs, hence the name tabless battery. Instead, the battery uses a conductive portion that runs along the electrode. Using this method, there is less distance for the electron to travel before reaching the positive and negative terminals. This is a win for physics, as explained by Elon Musk, the CEO. The biggest deal is that Tesla has used a radically different approach in battery design. It is basically what Tesla is known for anyway, taking problems apart to be able to come up with the most fundamental solutions. With this first principles approach, Tesla managed to change both the battery and the battery manufacturing process, making each of them better, i.e., both of them ended up being optimized. Well, it involved acquiring a few battery-focused companies, but hey, Tesla pulled it off at the end of the day. In effect, in one fell swoop, Tesla improved the efficiency and capacity of its battery, reduced the cost of production and the time taken for production. And if you think this is nothing more than a concept and will take time before actual batteries can be made, you can't be more wrong. Tesla's Drew Bagliano reported that they were already ramping up the production of the tabless cells in their pilot plant. Here is how the tabless design makes batteries better. With the tabless structure, as noted earlier, a time-consuming step has been eliminated in the production of the battery. That is the step of inserting the tab itself inside the battery. This simply means more battery in less time. Remember, Tesla foresees a shortage of battery supply as its own vehicle production increases and battery component suppliers can't keep up with the pace. Here is Tesla forestalling such a scenario. It also means batteries with larger capacities. The 4680 appellation added to the battery name means the cells are massive at 48 millimeters in diameter and 80 millimeters in height, packing more active battery material. This translates to a capacity to hold more energy in the same casing. Tesla sees a 16% increase in range over the same battery pack that uses the popular 2170 cells. Based on this change in dimensions alone, Tesla did more than just rearranging and eliminating some of the components of the battery. It also changed up the materials used. Tesla has been using silicone charged with lithium, but then switched to raw silicone. There is more to this that is beyond the scope of this video, but this move has multiple positive effects. First, more silicone could be squeezed into the battery, with resulting increase in energy storing capacities. Tesla estimates this could add 20% to the range of the car. Second, it cut down the costs as silicone is cheaper to source than lithium, slicing 5% of the cost of the battery. And third, it simplifies the manufacturing process greatly, reducing the time taken by the process. Tesla did a lot of work on the cathode of the tabless battery, and the results are astounding. Batteries today use cobalt, which is the best choice from a chemical point of view. However, the process of sourcing for cobalt is the nightmare for environmentalists. They are toxic and produce a lot of wastes. The supply chain is also unstable as most of the global supply comes from a single country in Africa, the Democratic Republic of Congo. Any unrest in the country that disrupts normal mining processes could result in a downtime in Tesla's factory in faraway China. Tesla switched to nickel in making its cathodes. Apart from lowering costs as nickel supply is less volatile, the manufacturing process is less complicated, generates less wastes, and consumes less water. It also makes it easier to design a recycling process for the batteries. With the tabless design, Tesla has also improved the thermal characteristics of the battery. The tabs can be a source of resistance to the flow of electrons, resulting in heat which would have to be handled in a complicated and expensive way. This means faster charging times and more efficient discharge for the car owner. In all, Tesla has managed to cram dozens of improvements that add up to a big advantage. Battery production will never remain the same. For Tesla, this simply means cheaper and better batteries. It also means a steadier supply to support its 50% annual growth ambitions. The EV industry is very sensitive to battery costs, as it represents a third of the bill of materials. Tesla's tabless batteries could have the cost per kilowatt hour. In that case, we could see the cost of EVs dropping significantly, or the range of EVs increasing dramatically, or a combination of the two. The $25,000 Tesla car that has proven to be elusive is now looking more like a reality. Musk himself had admitted that the cost of the battery is a key factor as to when and if the cheap electric car will be seen. But with the cheaper tabless battery, it may not be long before we see an unveiling. Will Tesla share its tabless design with other EV makers? That remains to be seen. However, the tabless battery is a radical take on batteries, and it is not surprising that it is coming from Tesla, a startup that has always managed to outdo itself. Just as Musk enthused, eventually every car company will have long-range electric cars. Eventually, every company will have autonomy, but not every company will be great at manufacturing. Tesla will absolutely head and shoulders be above everyone else in manufacturing. That is our goal.